If you want to use transformers to change voltage, you need to have AC electricity. Why? You have to have current that goes one way and then the other way, because I need to have a change in current, because I need to have a changing flux. And the only way you can get a change in flux is if I have a change in current. So DC currents, current that flows in the same direction, is not going to work for you. You need current that switches. You need to have a change in current. You have to have AC. So I'm going to do a real zesty version of something we can model as a transformer. And it's over here. And this is called the ring shooter. And the reason it's called the ring shooter is because it shoots rings. Okay, and I've got this single aluminum ring. And it's right up here. And it's on top of this. This is a whole bunch of iron packed into a piece of PVC pipe. So this is a magnetic material. Around the bottom of the iron are 400 turns of wire that are wrapped around it. And they're hooked up to the AC power supply, okay? Hooked up to the AC power supply through this power cord right here. So when I turn this thing on, there's going to be a big current in the bottom. It's actually 60 amps. We can only turn this on for a short period of time. Otherwise, it like blows the circuit breakers, and we really will be in the dark. So we just turn it on for a little bit of time, boop, and then the current is in here, 60 amps. Then that makes a big flux, and it's a big changing flux. It's going like up and down in the iron rod inside here, and then I get a changing flux inside this ring. So we're going to model this as a transformer. This is the primary. This is the one where I put the current on. How many turns of wire are in the primary? 400. This is the secondary. How many turns of wire on the secondary? 1. It's a single loop, okay? And then we can use our transformer relationships to say something about this. This question asks approximately what current would be induced in the ring under ideal circumstances. And it looks like this. It's a transformer equation. And the current in the secondary, and let's go back and take a look at that expression, is equal to the current in the primary times the number of turns on the primary divided by the number of turns in the secondary. How much current's in the primary? Oh, we can step forward 60 amps. How many turns of wire on the primary? 400. How many turns are on the secondary? How much current? 24,000 amps. Oh, now here's the thing. You won't really get 24,000 amps. And the reason is because the voltage just isn't big enough to make a current like this. The voltage works like this. V2 is equal to V1 times N2 over N1. What's the voltage on the primary? It's 120 volts because I've hooked it up to regular power outlet. What's the number of turns on the secondary? 1. Number of turns on the primary? 400. And so I only get 1/400th of the input voltage. And that's not enough to make that current go through here. But here's the thing. It's enough to make a lot of current go through here. Oh, and here's the thing. I've got a lot of current, hundreds of amps through here. Seriously, hundreds of amps. Oh, and it's a really strong magnetic field. What happens to a current when you put it in a magnetic field? Magnetic fields exert forces on moving charges. They exert forces on currents. And so it makes a very significant force on this current, really significant force on this current. And it's so significant that this thing will fly off. That's why I call it the ring shooter. And actually, it would fly off hard enough to like punch holes in the ceiling, and we don't want to do that. So I'm going to take this little box and put it on top of here. And then I turn it on. Oh, yeah. And it goes like that. And actually, it hits pretty hard. I mean, it hits really seriously with some force. Now, drop a ring on here. Box off. Try it again. But there's a difference between the two rings. Made of aluminum. Made of aluminum. Here's the difference between the two. I'm going to put them on the overhead camera so we can see the difference. They're both made out of aluminum, but one of them, we took a hacksaw to it. This is the second ring, and cut a little slot in it. So how much current is in this ring? 0. No current, and if there's no current, there's no force. This has got to be a current effect, because otherwise, this ring would do the same thing as that one. So it's not a material property. It just uses aluminum because it's lightweight, and it's a very, very good electrical conductor. Why is this a ring? It turns out it's a ring because that's the easiest one to build. Is it crucial that it's a ring? No,